Good morning and welcome to the first x86 virtual user group at Lenovo. We're all excited to be here and we hope you all are too. Thanks again for joining, and today, October 30th, we've invited our good friends at Microsoft to come talk about software-defined storage. As you may recall, our last couple sessions have been around that topic, and we're excited to partner with Microsoft. With that, I will hand it over to Rui. Rui, are you online?
Yes, thank you. Good morning. Can you listen to me correctly?
Yep.
All right. So my name is Rui. I'm the Lenovo OEM Partner Technology Strategist, and my role in Microsoft is work with Lenovo to integrate Microsoft products in their solutions, in their offerings. And in that aspect, today I'll be talking about software-defined storage on Windows Server 2012 R2 and the Lenovo ThinkServer highly available or continuously available solutions that we've developed. I'll be talking about storage spaces, which is a technology we have with Windows Server 2012 R2, and we will continue to develop in future versions. And how that integrates to make it to build a highly available solution, and what we have done with Lenovo to achieve that. During my presentation, if you have any questions, you can use the instant messaging window to address those, and I'll try to answer those on the fly while on my presentation. And to start, on my first slide, I want to highlight what's new in terms of storage when we released Windows Server 2012 R2. So it's not completely new today, but it was new when we released 2012 R2. We introduced for storage spaces storage steering, which is a big difference. Storage spaces was introduced in 2012 R2, sorry, in 2012, but it was the first deliverable of the feature. We didn't have that many customers adopting it, but with storage steering and data deduplication with 2012 R2, it made it more appealing to the customers, and we're seeing much more adoption of storage spaces from our customers. And that integrated with cluster shared volumes, something I will explain later on in this presentation. On the cluster, we can actually create a very affordable, highly available solution for our customers. So let me start with the storage spaces and what we can do with storage spaces. How does it work under the hood? How does storage spaces work? Basically, storage spaces, when we have just a bunch of disks, a JBOD or direct attached storage on our systems, we can assign those to be a storage space, so a storage space pool of hard drives. And with those hard drives, when we pull them, we can decide which ones we can pull and which ones we don't, or we can have different pools of hard drives that we can manage differently with different characteristics of different configuration. Once we have that pool, we can just create the type of virtual disks on top of that pool of hard drives. And can be just a mirror, can be a simple storage space. That would be similar to a RAID 0, or a parity space, or even dual parity, which is new on 2012 R2. So we have the same functionality or the same capability as on a RAID controller, but obviously everything is managed on the software level in terms of the virtual hard drives. So since it's managed by the software and it's developed, it's on top of software, it's more flexible to manage. It's flexible to reconfigure in case of need. Okay. So one thing that we also did with storage spaces is when we have a JBOD, we have the enclosure awareness. So we know on which enclosure the hard drive is. And in case of any error or any issue with a specific hard drive, storage spaces can identify those and actually identify the specific hard drive in the specific enclosure and signal that for being replaced, or send out a warning to the IT manager to replace or fix that failure. So with storage spaces, something that's really important, we need to keep the data integrity and make sure that in the background there's some checking going on to make sure that the corruptions are corrected in case there are any. For example, in case of one of the nodes failure or the system fails, when it brings up online, we have to make sure that the data is consistent and it's there. It works both with NTFS and with the new REFS that we introduced in 2012. So the customers, if you want to use the old NTFS, you can use it. If you prefer to start using some new technology and use the resilient file system, it's compatible too. And manage storage spaces as simple as PowerShell commands. You can use the server manager. That's the simplest way to create the virtual disk and the disk pools. It's using the server manager. But the PowerShell commands will allow more flexibility, more configuration possibilities, not because on the server manager, the UI doesn't expose all the capabilities. It's for the most used, or the expected most used configurations. If you use PowerShell, obviously you have more control of which parameters you can set up for the storage space, the disk, and the virtual disk. For example, you can set up the caching, which if you use the server manager UI, it will use the default 32 megabytes, but with PowerShell, you can set up that caching for as much as you want to use there. So PowerShell more powerful to control and manage the storage spaces. In terms of VMM, the Virtual Machine Manager, it can also deploy and provision storage spaces. So if you're using System Center and you want to provision storage the same way or the same console you provision your compute and your networking, you can do it from the same console and manage storage spaces from there and manage your virtual storage from there. I don't have it on this slide here, but storage spaces allows for fixed and thin provisioning. So if you're using thin provisioning because you don't really know how much your storage is going to grow in the next couple of years, you can use thin provisioning, and you can add drives on the fly and make that storage flexible and growing in time as needed. And the continuous availability, it's integrated, as I'll talk about later on. It's also available with Windows clustering services. So basically, we just merge the two or combine the two technologies and made a resilient file server that I will cover later on. So basically, to start, before I go deep dive into the spaces and the file server cluster, for you to understand how that works, we have two nodes that are connected to a JBOD through a shared SAS links to the JBOD. And on top of that, we create the space or the virtual drive with storage spaces. So basically, we just pull the drives on those JBODs, and we create the virtual drive on top of them. On top of the drive we created cluster shared volume on the nodes, and with that we get basically a file share which is resilient across the two nodes of the solution. Although the drives are owned by one of the nodes, the file share will be shared across the nodes. And I'll explain how it works on the next slide. Basically, once you have that cluster configured, you can build any Hyper-V or workload solution on top of that. So Hyper-V will allow for creating the virtual machines on top of those cluster shared volumes, and you can live migrate any virtual machine from any Hyper-V nodes as long as they are running from this cluster shared volume. And with this initial basic configuration, in case of additional resources are needed, this can grow as big as the customer will need it. So if you need more nodes to support that cluster, you can add the nodes. If you need more nodes to provide more storage, so more JBODs, you can actually add those to the configuration. And it's a dynamic and elastic configuration that can scale out to address a larger infrastructure. So basically, why we're doing this? Why we're doing this? The software-defined storage and this type of configuration? Why we're allowing it on 2012R2? Basically, we want to reduce the cost per terabyte to our customers. The traditional storage solutions are one of the most expensive components in the data center. So we wanted to address that with Windows Server. Also, in terms of the number of IOPS we can address with these type of solutions, we want to make it a very fast and reliable solution. So that's why we want to combine the storage spaces with a cluster, and obviously minimize the number or the need for maintenance or operational costs associated to managing your storage. So using Windows and just software to manage the hardware, and we're talking about commodity hardware, we think we can make the operation of this type of storage solutions more cost-effective. So I've talked about the dual parity on storage spaces. So one of the key points we introduced to keep the resiliency, but at the same time reduce the cost. So we do allow for dual parity on storage spaces. If you're using some sort of archival or backup workloads, dual parity might be the best solution, mainly because it does the rebuild times are minimal. So the parity for data is kept duplicated. In case of a hard drive failure, we can just do a copy operation of that parity to the new replaced hard drive. There is no overhead for recalculating the parity and rebuild the virtual drive. So makes it more efficient in terms of failure. We support that on the clustering, and the cache, which you called at the beginning journaling, improves the random workload performance. So basically, if you have a optimal cache size, the parity will work very well with storage spaces. Basically, if you want to have the best performance, you just try to understand what would be the maximum transfer size you want to address, and you try to match that with the caching if you have that space available, and the copy process will be really fast. And then the parity, once that information is cached, is just calculated on the storage spaces nodes, which allows for a fast transfer rate at the beginning, and then delay the calculation of the parity for a later time when the system is available for doing so. So something also new on 2012R2 is storage tiering. So we didn't have this feature when we released storage spaces in 2012. We introduced that at R2. Basically, we allow for creating a pool of max SSDs and hard drives. Storage spaces will identify those SSDs as such, and will identify them as fast storage. And any hard drive or any spindle will be considered as a low access storage. With that, storage spaces can identify the most frequently accessed files and place those in the SSD tier. And once those data files are not used as regularly, they are moved to the hard drive tier. Because obviously, if they're not used as regularly, there is no point in having them on a fast storage solution. And that's done on the fly in the background, without the user actually understands where the drives hold the data. Obviously, the IT manager can go to the storage spaces drive and check where each file resides. Can also set a schedule when the files are identified and placed on the hot data or a cold data tier, and also can set the parameters, what is considered a hot data and what is considered a cold data. The tier here is at the file level, so a file is completely moved from one tier to the other when that happens. The default setting being 6 hours. Every 6 hour storage space, this is just checks for files that have been accessed in that index 6 hour window, and just move them if they've been used or not in the background. Write-back cache. So as I've explained before, the write-back cache, in case storage spaces identifies that it's a tiered virtual hard drive, the write-back cache will be by default placed on the hot data tier, so on the SSD tier. Obviously, that's the fastest storage, and that's where we want to have the cache for our data. It will run faster. If we have a Parity, that's a Parity hard drive, this write-back cache will be always a mirror, so it will be stored in two of the SSDs, at least in two of the SSDs, just for resilience in case the system fails. We always have the data on available and has the mirror. Once the cache is flushed, basically what happens when that happens is the parity is calculated and the data is moved to the portion of the hard drive where the parity resides. So we have a resilient system that in case of failure, we don't just lose data at that point, because it's copied, and it's copied in the mirror during that process. Moving on to deduplication, which is not a storage spaces per se, but it's related to storage spaces. In terms of the software-defined storage technologies that we have in 2012 R2. Data duplication, also introduced in 2012 R2, allows for a better usage of the storage available. Basically, it's just a service that scans the hard drive at the block level and identifies which blocks are duplicated. And once those are identified, the system will just keep one copy of the duplicated data to those files. In terms of how much would that save you space on on the system. If you're running virtual machines, mainly on the virtual environments, most of the operating system hard drives will have duplicated files. So that's where you see the most gains in terms of the duplication of your data. Because you keep just one copy of all that. Although you will see on the file system your different virtual hard drives, just one copy of the data is kept. If you have a library of VHDs that you keep, for example, on VMM or Windows deployment services, you may have copies of duplicated information, but they have minor changes or minor differences between your files because the majority of the content is just duplicate. There's also a very good improvement of on data duplication. And then general files. We know that most of our users will keep copies of files on each one of their systems or each one of their shares. Probably just for a presentation like this, they will, when we share this, most of the customers or most of the users will have each one his own version of that file. In those scenarios, obviously, data duplication will take a very good benefit on your file servers to reduce the amount of space used. And the users of that file share or SharePoint, for example, will not notice the difference because they will also always see their own file in their share. With that, moving on to some file and SCSI storage technology introduced or improved in 2012 R2. So basically some scenarios, both for the client and the server side. Obviously, we focus most of the work on the server side, but most of these improvements also apply to the client side. And we also done some work not only on SMB, which is the preferred protocol on Windows, but also for non-Windows clients. We also did some work to make sure we were compatible with the latest features of NFS and the iSCSI target that was a separate component in the past. We include that in the OS to make sure that we can work with other technology other than Microsoft's Windows. Basically, in terms of cloud deployment and scalability, for you to understand the scale of a highly available solution so that we developed with Lenovo. So it's the lower part here of the SMB. It's basically the solution. 2 nodes directly connected to a JBOD that exposes some storage to what will be as many Hyper-V clusters as you can add there. So that's basically the simplest way to put it in terms of managing or building this type of solutions. And again, why we're doing it, obviously reducing the costs, the performance, the scalability, and from the previous picture, you can understand that you can scale out as much as the system can handle the data there. You will notice that most of the Microsoft technologies for which is mostly scale out other than scale up. It's easier to manage. It's related to commodity hardware that makes the solution obviously with a lesser cost than a scale-up solution. And reliability and manageability, those also 2 pillars important here. I've talked about the reliability of storage spaces, but also manageability. Again, we can manage any of these features from Server Manager, which will be the entry-level management. We can use PowerShell for automation and for most of the scripting and customized scripting you need to do with this type of solutions. But the key management or the preferred management for this type of solutions would be virtual machine manager. So if you have System Center, that will be the best option to manage this type of solutions. So in terms of features, we introduced SMB Direct version 2 on 2012 R2. Some improvements on AFS replication. In terms of diagnosis, there is some better diagnosing on SMB, the new SMB 3. We can have a better control of if there's something wrong, what's going on. Automatic scale-out rebalancing, I'm going to talk about that in the next slides. And some improvements in terms of the iSCSI target. Now you can manage the storage using the SMI-S Provider for the iSCSI targets, and for most of the storage spaces can be managed by SMI-S too. We had our own protocol before 2012. With 2012, we introduced SMI-S to manage, being a standard to manage the storage portion of Windows Server. So SMB Direct. So some numbers and some focus on what SMB Direct means. You can also see it has RDMA. Basically, we just offload the network traffic from the CPU to the NICs, and we allow them to just manage the traffic directly. That means that the NICs will be more suitable and will have more power to manage and faster workloads and faster IOs on the network level. So that releases the CPU to do other stuff and allows for our network vendors and our network partners to work on silicon that addresses this technology in a direct way and can manage the SMB protocol directly without the need for much memory or CPU usage on the systems. Basically, if you have SMB Direct on the system, what the CPU will be doing is just commuting packets from the network card to the drive controller, and that's mainly it. Not much more. It's just passing on data from one point to the other. So the CPU actually becomes a switch of data. In terms of SMB on a cluster, and the cluster shared volume. So the cluster shared volume that I was talking before, how did we improve that in 2012 R2? Basically, before 2012 R2, SMB share on the cluster will be owned by one of the nodes of the cluster. We changed that behavior and how that works on 2012 R2. And basically, the two nodes of the cluster are active nodes. With the cluster shared volumes, the cluster clients being Windows client or Windows 8, or the Hyper-V nodes that are running the virtualization from this storage, will be redirected to the most available node of the cluster. And in this case, it doesn't matter really which node owns the storage, because between the nodes, they will identify who owns the storage, and they will replicate the data and move on the data to the correct nodes in their private network. So in the back end or the backbone infrastructure, that traffic will go through there. So basically, without the SMB client understands, he's just being pushed to the most available node of the cluster, which makes it highly performant and resilient. In this picture here, you see that the node on the left owns one virtual hard drive, while the second node owns the second. That configuration is it's possible because we're running storage spaces here, and they're basically 2 virtual hard drives on top of the physical hard drives that are on the JBOD. So automatic rebalancing. Basically, in case you have a set number of clients connected to your cluster, and suddenly a few of them just drop the connection, and the cluster is aware of that, or identifies that one node is more loaded than the other node, and the cluster itself will rebalance where the SMB clients are connected to, and will rebalance the workload between the 2 nodes to make sure that both the nodes are equally loaded in terms of requests from the client systems that are loading information from them. So makes it, again, a more resilient system. And this is dynamic. If one node fails, obviously all the clients will move the connections to one of the nodes. If that node comes back online, the cluster will automatically rebalance after that, and will spread the loads across the nodes too. And there is no action needed for this. This is the default behavior on 2012R2, so there is no user intervention to rebalance that load between the nodes. It's just automatic out of the box from the cluster services. Another thing that can be done with the new SMB protocol is create some bandwidth limits. Basically, it's a QoS for storage. We can limit how much a specific machine or specific virtual machine can drain in terms of the SMB protocol from a node. Basically, in the scenario we want to address here is, imagine you have one SMB client in that cluster that for some reason is behaving badly and just draining out the SMB connection, and it's just clogging the cluster. So with SMB bandwidth, we can limit how much a given machine can take off that bandwidth. And if for some reason that scenario happens, that the machine is behaving badly, it will not affect the remaining of the SMB clients connected to the cluster. It will keep those machines running at the desired performance, and the one that's not working as it should will just have its bandwidth limited to as much as it has available at that point. And that control can be also delegated, meaning that instead of controlling the nodes one by one, we can actually control on the client side. So we can decide whether you want to do the bandwidth management on the cluster itself, but we can also do it on the Hyper-V servers that own that have the workloads running. So moving on to NFS, basically to say that we support the latest version of the NFS with Windows Server 2012 R2 and this high-level solution. So NFS is also a clustered protocol, and we can take advantage of storage spaces to hold the NFS shares. And this is obviously to be compatible with non-Windows clients and non-Windows workloads. So if you have VMware as your preferred virtualization solution, you can still run this highly available solution, and have, instead of having the Hyper-V cluster on top of it, you can have a VMware cluster on top of it, and run your virtual machines on a different virtualization platform. So as I said, the NFS version 3 has some limitations in terms of the highly available that we would like to have on our software, and we move on to version 4.1 to make sure we had support for highly available more than continuously available. In terms of iSCSI, as I said, now it's included on 2012 and 2012 R2. If you're using older software and you want to use iSCSI, you would have to install the iSCSI target separately. You have your own interface for managing it. Not the best user experience. With the iSCSI targets on 2012 and 2012 R2, that's included on the server manager, and you can just manage from a very simple interface. You can manage how much you want to provision for iSCSI and other settings as what type of virtual hard drive you want to deploy with iSCSI. And obviously, if you want to format the drive up front or not, you can also do that in this new UI that makes it much easier to deploy iSCSI targets. As I said, we can also manage that using the SMI-S protocol or the provider for is a standard. If using VMM Perfect, you'll be able to manage the iSCSI from VMM. If using any other management tool that uses SMI-S to manage the target, you can do that too. It's a standard. So there is no limitation in terms of how you manage the Microsoft iSCSI component there. With that, I'll move to the cluster in the box concept and what we've built with Lenovo to address all these technologies that I've just talked about, storage spaces, pulling off the hard drives, the virtual hard drives, deduplication, clustering, SMB over cluster shared volumes, and the rebalancing of the SMB clients. So all those technologies put together, and we build what we call a cluster in the box. With Lenovo, it's a set of components, but it has exactly the same functionality. So in terms of, we first released this concept with 2012. We want to make a continuously available solution for storage. We want to include all the major investments we've done in 2012 R2. So we reviewed the concept and we reviewed the features we want to address with 2012 R2, and we want to make it highly available. Also, the question is why we're doing it. Very important here, which market we want to address. Let's move on to this slide here. Basically, before this cluster in the box concept, we had either the very simple storage solutions at the low end, or on the other side, we had the very scale up and scale out, very expensive and custom storage solutions from some vendors. We didn't really have much in the middle there in terms of commodity hardware with the same features. So the commodity hardware, meaning the price of the low end, or almost the price of the low end, and the same features as the high end. So we felt there was a lack in something in the middle there that would address highly availability, simple to manage, that would leverage storage spaces and the storage tiering. So we've built this concept of the cluster in the box, which basically it's commodity hardware with high-end functionality. And in a nutshell, how is that? What's inside of a cluster in the box, basically? As you've been seeing from the rest of the presentation, it's a 2-node cluster. that has a storage controller. It has a specific storage controller that is connected to a SAS expander and then to an external JBOD. Basically, the storage controller, since they're both connected to the same JBOD, the two nodes of the cluster can, at a given time, own the storage and just be always working on or taking advantage of that. So it's a highly available solution. In case one node fails, the other node can take ownership of the storage and just continue to work. It's simple because it's pre-configured or pre-wired. It's just a matter of getting the box, putting it on the rack, and start it up. It should just run. And again, it's just commodity hardware. A simple JBOD. The storage control is the specific storage control, but then it's just regular Lenovo hardware. So things to consider when building these type of solutions. We have different components: the network cards, the PCIe bus, the SAS drives, the SAS controller, and the SAS drive. So depending when or what you were working on when you're choosing the solution, we have to see what capabilities you want to have in terms of how much network we want to use, how much those SAS controller or the SAS drives will have to handle IOPS to manage the workload, and is the CPU and the PCI Express fast enough to hold that? And I've got this data here in terms of some bottleneck points to consider when assemble these type of solutions. Basically, you don't want the entry-level network card because might just not be enough, because if you have too many drives or too many capabilities on the hard drives, the network cards would not be able to handle. On the other side, having too much of a network, but then not enough hard drives or not enough CPU power to manage those hard drives, having that really fast NIC will not really take advantage of that. So it's something that has to be balanced, and something that we thought about when we built this Lenovo solution. And the options we have there would give you what's the line, the second column here, which is the most balanced setup. Obviously, you can go as high as you want and just go faster and put all the high-end components in there and go for column 4. But then the cost of that might not be just as accessible in terms of the performance increase you're going to have there. So some points you need to consider when building these type of solutions. So, and then basically the building blocks of the cluster in the box solution. As I said, 2 nodes with a set of JBODs attached. Normally it's 1 JBOD, depending on how many storage you need. With today's capacity on the hard drives, 1 JBOD will be more than enough for 2 nodes. And then on top of that, you scale out as much Hyper-V servers, and you put the workload in there, and they should be able to just manage that workload. This type of configuration obviously allows for the live migration, so no downtime in case one of the storage nodes fails. Obviously, the Hyper-Vs will be up and running all the time. If one of the Hyper-V fails, all the VMs from that node will be migrated to the remaining. Can be migrated to the remaining Hyper-V servers, and again, the infrastructure will be always up and running. In terms of scale of the storage itself, so you can scale up, you can add more JBODs if needed, or you can scale out, you can add more nodes to the configuration. You can have 3, 4, as many nodes as you want there, and scale out the storage portion too. So basically the same thing, but scaling vertically. You just add more components within the storage node itself. You can add more memory, CPU, in case of need. You can just change the network card if you need more network bandwidth there. So you can also do that. So some scenarios or key points here to take in consideration in case you're using storage spaces. So disk utilization can increase in case you use a mirror space versus a parity. So you have to take into consideration that fact. Obviously, a mirror space, you lose half your storage because you have a duplicate of all the data. You can obviously use parity, but you have to think about the resiliency. And in case you're not using the dual parity, you have to consider about rebuilding of the parity at some point in case of a one hard drive failure, and that will take CPU cycles on the storage nodes. So the baseline recommended configuration, at least 12 hard drives, if possible, put it 24. Do have storage tiering. It makes your storage space solution way faster than just using hard drives. And you'll be able to use tiering either automatic with the default configuration, or you can actually manage what the tier looks like, what qualifies as hot data and cold data, and how frequently you want to move the files from hot to cold, the cold tiers. In terms of SMB3, I know that not all the customers are using SMB3 yet. There's here the call to action. Just try it, and you'll be amazed how fast SMB3 is compared to SMB2 on Windows 2008. And it's not even comparable what SMB1 was on XP in 2003. It's light years ahead in terms of performance compared to SMB1. And again, the scale-out file server that I've been talking about all this time, so storage spaces and the clustering with CSV, together with deduplication, it's one of the best scenarios for a VDI solution. So VDI will use mostly virtual hosts to host those virtual desktop sessions, and all those virtual desktops are equal. So if you're using dedupe on that scenario, you'll be reducing the amount of space you need on your storage solution. So it's highly recommended to use the dedupe on these VDI scenarios. And with that, I finished my presentation. If there are any questions, I'll be able to address those. I also like to say that on the content, on attachments for this presentation, on this session, I've attached, let me see here, I've attached the ThinkServer HA solution, and if you want to download it, it should be available there.
Very well. Thanks again, Rui. There is one question out there right now. I do want to just remind everybody that you can post questions via the chat window. Within link, it looks like a little cloud icon.
Sorry. All right. Yeah, I missed that one. Sorry about that. Let me see. Okay, so in terms of certification of the JBOD, so it doesn't really have to be certified. We recommend it to be because what certification means is the device has passed our Microsoft tests to make sure it is compatible. So basically, we have the storage spaces team has a set of tests that we can run against a specific hardware, and those tests will output a report saying these features available, these other features available. Basically, enclosure awareness is available, identification of the hard drive is available. So features like that, And if we pass all the requirements from the storage spaces team, the vendor can just say, well, I'm going to publish this as certified, and it's certified. So the fact that it's not certified does not mean it will not work. It just means that for some reason, either the vendor of that JBOD did not apply to have it posted as a certified device, or did not run the tests. But just because it didn't run the test doesn't mean that it does not comply or does not work. Obviously, it's a better experience if the device is certified. You have the guarantee that that it will work correctly with storage spaces.
And be supported.
Well, yeah. So in that case, we'll be supported. In case it's certified, it will definitely be supported.
Okay.
If it's not, we'll probably have to go through some Q&A and back and forth. Does not mean that the customer will not be supported from our side. We'll have to evaluate if the hardware at that point is supported in case there is an issue, and work with the vendor to see if we can address and help the customer. But we just won't say upfront, sorry, doesn't work. We try to, normally, we from Microsoft, we try to help as much as we can.
Okay. And then just for the audience, the SA120 is on the Microsoft HCL listing, so that is covered.
Yeah, that's one of the things since we work together, it's one of my roles as working with Lenovo, is make sure the solutions we build is certified and the customers are comfortable deploying them, and obviously certification is one of the key points there.
Great. And while we're waiting for more questions to possibly trickle through here, I will note that the session was recorded and there will be a replay available as well as the presentation materials on our wiki website. And a follow-up email will go out with that link. So far, I'm not seeing any other questions. Any other comments or just things you'd like to talk about, Rui?
No, I hope I was clear enough in terms of what this solution is all about. But if there are any questions, if not now, in the future, if you can forward that to me, I'll be very pleased to answer any questions that are related to this solution.
Absolutely. If anything comes in to the email address, the x86usergroup@lenovo.com, we will definitely forward them as we see fit. Also, feel free to reach out to your local Lenovo account team if you want to pursue this in more detail. Okay, well, it doesn't look like there's any more questions at this time, Rui. So we'll go ahead and end the session. Thanks, everybody, for joining.
Okay.
And, Alex Fields has how to download the detachment. So if you look to your link session, at the bottom there's a little computer monitor screen right next to the microphone to the right of it. And depending on the version you have, I guess it might be in different places.
Right. Or let me just do this. I can also put the link here on the IM.
There you go.
So everybody can access to it.
Okay, Alex is good. All right, well, thanks again, everybody, for joining, and looks like yep, there will be more presentations added to the wiki page, so we'll get those added, and you'll have all the links available for the presentations.
Okay. I have a question here. So Eric is asking, is this a SaaS only? Yes, this is a SaaS only. SATA does not allow for a shared bus. It's a technology limitation on the SATA technology.
Mm-hmm.
So that's why using SAS at this point. If you want to use SATA disks and we are just close, yes, it has to be a dual ported drives because in case of the failure, the enclosure will be either connect to one node or the other. If not, at least the enclosure will have to manage those drives. If you want to use SATA disks, if you want to use NVMe, for example, which is attached to the PCI-S bus, you have to wait for the next version of Windows. I'll just say that. Okay, and I think that will be it.